Well, good morning and good afternoon, everybody, and welcome to today's webinar entitled Improving the Efficiency of Engineering Workflows. My name is Andy Osborne, and I'm joined today by Christine Reck. In terms of the agenda, we're going to give this brief introduction right now, and we're then going to go over a number of engineering workflows in a fairly rapid succession. The topics we're covering today are P&ID data quality, 3D symbol creation, spec data quality, migration of PDS data, progress reporting, and visualization. So there's an awful lot to get through, so it is going to be fairly high-level cursory glances at what we're doing. We're then going to summarize that. We want a bit of feedback from yourself, and from there on we're going to go into the audience questions. So please feel free to post any questions as we go along. We'll get to those at the end and go through them all. Okay, so without saying any more, let's begin. I should just say, by the way, we are going to record the session, so you will be able to view this in about 2 days after. So don't worry if you don't catch it all as we go through it. So let's look at the business case. We are considering that an owner-operator wants to enlarge an ethylene plant. The plant was originally designed using Integra's PDS, and for the purpose of this we're talking about two separate organizations that we're calling 3D and 2D who will be responsible for the execution of that. So in the first business case we're going to look at P&ID data quality. And the 2D organization has to create the P&ID diagrams using SmartPlant P&ID. The diagrams have to follow the rules of the owner-operator corporation. So the task that we have is to check the quality of the P&ID data. Now at this point I'm going to hand over to Christine, who's going to explain a little bit more about what this entails.
Okay, so hello everybody also from my side. The quality assurance module is the right program to help you checking quality, not only in PID but also in other applications. So what you see on the left side of the screen is a list of all the adapters that we have which look into different applications, and it is visible here that you can even dock it to Excel or to some custom adapter. And in the end you will get reports as an output and also some graphical output. So Andy, please move to the next slide.
Yep, sorry. This one, yep.
Yeah, sure. The typical interface of the quality assurance module allows you to create company-specific rules. These rules, they are stored in files. They can be handed over to contractors and can be used actually on both sides to control the data. And the configuration of the rules has two possibilities: a visual interface, which is a very easy way to configure rules because you have access to all the properties dynamically and you have predefined queries to use in there. But you can also use a text configuration which gives you the possibility to make more complex queries with some extra functions which are available at that point. The grid which is here above is displaying the data, which in this case is coming from PID. And here you can apply rules. So for instance, all the item tags that end with W are shown in this orange color, and you can also apply some other checks like empty material class, missing nominal diameters, etc. So if we have a look at the results, maybe first at the report, you can see that we can generate Excel reports which display the results of the quality checks. And the colors that are defined in the rules are copied to Excel. So for instance, this green color means an instrument in the PID has no modifier. The blue color means that the instrument, which is a control valve, is not really associated to a pipe run. or the red color is a loop without tag. And we also have the possibility to add virtual columns, which means we can only display instruments without modifier, so you can create your own queries and use the autofilter in Excel to display this result. And if we click on the second sheet in the Excel, which is called filters, we can also see what do the colors mean. So this is a very good lookup table for you, that you can see this color means that this was a problem in the PID. Okay, let's go back to the slide. And have a look at the PDF with markup. So this is another result that is coming from the quality check. You see that there are these marked PDF indicators with tooltips which would display what is not okay in the PID. So the combination of the table grid-like interface and the graphical marked PDFs is a very good way to hand it over to the authoring people so that they can make corrections in the PID, and then you can have another run which will show you the status sometime later. Okay, let's move to the other graphic. The other graphic is an example of a PDF with highlight. So this means that any row that is visible in the quality assurance tool in the grid can be highlighted and printed out in PDF, and you can very easily generate packages of files displaying interesting information with a color coding applied. Okay, let's go to the next slide. As a summary from what we've seen, you can perform data auditing with company-specific rules. You can verify your data prior to loading it into enterprise systems or prior to handing it over to the client. As you've seen, we can also generate PDF files with markups or color coding, and the packages of reports and graphics provide very valuable information to improve the quality of the data. So I hand back to you, Andy, now.
Okay, thank you, Christine. Okay, so what we're going to do is move on to the next business case, which is around 3D symbol creation. So the 3D organization has to create and maintain the 3D model and the catalog in Smart 3D. So for new Smart 3D piping specs, some symbols are missing and have to be added to the Smart 3D catalog. So the task is all about creating new 3D symbols for Smart 3D. Okay, so if we just look at the overall requirement for getting a symbol, first of all you need to understand what symbol you want and how it's going to function. And then you really need to deliver two things. The first being a bulk load datasheet file, and the next the coding either in Visual Basic or .NET to pass on to Smart 3D. So these two items are required. So what we have is 3D SymbolDesigner, which allows us to create the symbol graphically. And we're using a WYSIWYG, what you see is what you get, a user interface. So as we build the symbol from primitives, we see this being formed and displayed on the screen. We can add parameters to those symbols, so we can make each one of those perform based on the parameters that we enter. And then we can link that through to the Smart 3D interface. Having done all that, we can then create the symbol, and what that will do is basically output all of the Visual Basic program, all of the bulk load sheet that we require for loading. So this saves a huge amount of time in terms of symbol creation. Typically we can use this for equipment, piping, pipe supports, etc. And these are just a few examples of what we've done in the past. So you can see for fencing, pieces of equipment, etc. So when we consider what this delivers, we're talking about easy placements of objects in this WYSIWYG graphic user interface. It delivers an 80% reduction in man hours for the creation of symbols if you compare that against the manual coding effort that would be required. In most cases, the symbols can be created without the need for any Visual Basic programming knowledge. However, when you do require multi-part assemblies, typically you will use the 3D Symbol Designer for the creation of the parts, but you would then need some Visual Basic programming to write the assembly joining code. So what you're getting out of this are time savings through automatic creation of the Excel bulk load sheets, the Visual Basic source code, and the symbol documentation. Okay, so we did say it was going to be very quick, so as you can see we're flying over this. The next business case is really around spec data quality. So under this scenario, the 3D organization has to create and test piping material classes for Smart 3D. And the necessary Smart 3D catalog bulk load files are created by a customized material management system. So the task in this case is to write and test piping material classes for Smart 3D. So in this case, what we're doing is we're using an application called SpecXpert. So we have the Smart 3D catalog. The first thing that we can do is test that the components will place correctly in the Smart 3D environment. So that's one side of it. We physically place the components and we get a quality report on the placement of those in an Access database. The next thing that we can do is we can extract the bulk load files directly from the Smart 3D catalog. So we can then get a bulk load sheet that we could take across to another project for loading based on the existing contents of that catalog. The other aspect that we've added recently was the ability to do a comparison between two different bulk load sheets. So one of those bulk load sheets may reflect the current status of your catalog, and the new bulk load sheet that's coming in here may be a bulk load sheet that says this is what we really want the project to be configured to. In simple terms, we can compare the difference between those two and then generate a comparison bulk load sheet that would bring one in line with the other. And I'll explain a little bit more as we go forward. The user interface for generation of bulk load sheets is very straightforward. We have a list of the piping specs within a specific project. We then have a number of items that we can select for output. So this can be the code list, the generic data, the plant options, the insulation data, for example. By simply selecting those and then hit create from catalog, it will then write out those bulk load sheets for you to do whatever you want to do with them. When we start looking at the comparison, this is where we have these two different bulk load sheets. And when we run the comparison, we then get an output which shows us the differences. So this is a summary table at the beginning. So it's saying on the piping generic data, we've got one addition, one modification, and one deletion. So that's just a summary of the actions. On the bulk load sheet itself, it's represented as you would expect, where you have a modification, a deletion, and an addition shown within that bulk load sheet. So by running that comparison, it will then bring the system in line with that supplied bulk load sheet. So what it enables you to do is fast and easy extraction of bulk load sheets directly from the Smart 3D catalog. You get 100% consistency between the bulk load sheets and the Smart Plant catalog. You can compare files from the current Smart 3D catalog against new and other bulk load files, and you can easily transfer the specs to other projects without having to take account of 30 or 40 different bulk load sheets that you may need to sequence in order. And of course you can choose exactly what it is you're exporting, so if there are specific company specs that you don't want to supply to other people, you can leave those out and therefore protect your corporate IP. So on the SpecTester function, this is when we're testing the components themselves. And again, the interface is very simple. We have the ability to select the project, and from the project we then see a list of the specs. We tick which one we want to test, and then it will place all of the components and the combinations of components into the Smart 3D environment itself. Any issues it finds immediately get logged into the to-do list report, and you can then use that for further investigation. So what you get from this is a comprehensive quality assurance check for all components on your smart plant piping spec. You don't have delays caused through people trying to place components and then not being able to. If you were to do this kind of checking manually, this would save around about 90% over that time. You get a validation of the specs provided to you from a client or contractor prior to using on that, and of course what we're really all about here is overall reduction of project costs as well as time savings. Okay, so that really covers the spec data quality side of it. The next one we're moving on to is migration of PDS data. So in this particular scenario, the base for the modifications within Smart 3D has to be the existing PDS model. Now, yes, you can reference PDS models into Smart 3D, but in this particular case, the EPC wants to modify that model going forward on the project. So therefore, just a reference isn't going to be sufficient. So right now, the task is to convert the 3D model from PDS to Smart 3D. To do this, what we need are the PDS RISDump files and the MicroStation DGN files. And very simply, we're using the MTO schema, the DGN graphics, and remodeling that within the Smart 3D environment using this PlantReModeller technology. Now, we can supply the PlantReModeller technology, but also we can provide this, as we are doing with many companies, as a turnkey service. So in other words, we will take the PDS model and deliver back a Smart 3D model fully QA'd and checked. The overall concept is that there's minimal configuration and setup needed. There's very simple mapping. It's designed for use by engineers rather than administrators or IT experts. And the deliverable clearly is we're taking PDS and delivering it into Smart 3D. From a discipline point of view, we can take equipment, piping, structure, non-PDS items, and drawings, and the model coordinates can also be translated. So when we start thinking about equipment import, all MicroStation attachments will be imported. So if you've got equipment models that were developed in a mechanical modeling system, that will also bring those across. From the piping point of view, we have typically tried to make the graphics identical within Smart 3D to the same as they were within the PDS environment. Now, in some cases, you may get the same component between the two systems, but graphically they're represented differently. What we've tended to find is that a lot of our clients want to see exactly the same PDS graphics within the Smart 3D environment. Having delivered that, extraction of the isometrics is possible. Supports get placed as design supports. And what we also do is generate a quality assurance report automatically. So this will verify that these components have actually been placed. And not only that, that they've actually been placed in exactly the right position. So we've got a very good, comprehensive quality report to know that what we started with is what we've ended up with. There will be some requirement for manual intervention at the end of this, but we use that report as the basis for doing that. From an import of drawings point of view, we can take the drawings, the views and namespaces, they're automatically created. We map the view styles, and we take the user-defined graphics and import those as well. So what we end up with is a Smart 3D drawing which is identical to what we started off with in PDS. So in terms of the benefits, we get a rapid delivery of the imported model. So the end-to-end process is much faster than any other method currently available. And again, what we found is there are different methods of dealing with this, but usually there's a lot of pressure on time. Yes, we can be cheaper, but the time for delivery is one of the most critical factors that we come across. We deliver a fully intelligent model that can be edited and further developed. And of course, you could use this approach for reuse of engineering because you can just select parts of the model for import. And as I've already mentioned, we get this QA through the automated report. Okay, so that covers the PDS to Smart 3D migration. The next one, business case 5, is progress reporting. So in this case, the owner-operator, could even be the EPC, wants to understand the progress of the project itself. So the task here is to check and control project progress. Well, a lot of progressing and tracking is a fairly arbitrary thing. Some people are much better at it than others, but I mean, you've got a number of combinations of things that you want to look at. So for example, it could be the number of pipes, it could be the number of man hours, it could be the tonnage of steel. But ultimately, you need to try and give an accurate representation of where you are at in that particular process. So the technology that we have for this is called ProgressXpert. Now, you saw with Christine and the quality assurance module, the data quality checking, that we had access to a number of different platforms. Well, we used the same mechanism that we used for the quality assurance module for ProgressXpert. So if we want to check progress for P&IDs, instrumentation, for the 3D model, or even just based on Excel spreadsheets, we can do that. The custom report adapter means we can apply this to any other in-house system or data source. Ultimately, we get reports out of this which shows the current position that we're at, and we configure that to suit our requirements. The system itself was developed using an HTML user interface, which gives you the ability to access this from any device that supports HTML, including Apple's and Android devices. In terms of the workflow, there are basically 3 stages. You've got inputs, evaluation, and then reporting. So from an input point of view, we try and automate as much as we can using those data sources that we looked at before. And it's based on that data sources we'll do the evaluation to get the status. Of course, we can also have manual input as a way of progressing our data. So the evaluation criteria that we apply to this can come in the form of man hours, deliverables, tonnage of steel, or just percentage complete. So that really can be any kind of unit that you want to apply for the rules of progress. Typically, we define excuse me, the milestones. So the overall milestone would be the project, and that may be made up of the various disciplines, and we may have sub-packages that go within each one of those. So this progressing maps directly to the way you want to progress your project. It's not a pre-described way of functioning. So we then analyze that information and then generate the reports either as Excel tables or as graphical reports. So we do employ this auto-progressing to provide a cost-effective method by reducing manual input as much as possible. So we look at the data, we have rules defined, and we auto-progress the status based on those rules. Those rules can be as simple or as complex as you like. So in simple terms here, this example, if you haven't started something in a 3D model, then that would be 0% progress. If you start the line, we may equate that to a 10% progress. Support placed 30%, created the ISO 60%, line approved 80%, and the isometric transmitted might equal 100%. Just a pure example, but it gives you something to think about. The end result of that is that we can then start looking at various reports. And so, for example, we might see an S-curve based on the disciplines or the overall project, or broken down by units, areas, systems, individual tag items if you really wanted to. So we've got the data, we can then slice it and dice it to look at it any way you like. This other graph down here is basically showing the man hours versus progress. So what we really want to see is an equivalent going forward, so that or more progress than we've used man hours. But again, as I said, you can represent the data in any different way you like. Okay, so that was the progress reporting. What I'm now going to do is hand back over to Christine to explain about the reporting. Let me just do the introduction first. In this case, the owner-operator corporation wants to compare two different states of the P&I diagrams it got from the 2D contractor and ensure that the 3D model was modified accordingly. So here what we're going to do is check the differences between revisions provided by EPCs. So, over to you, Christine.
Yes. So, as you can see in the slide, we can check for differences between all the applications that are listed on the left side, and also for two different stages of one application, or even two different plants which maybe originally started from the same one, and we can try to find out the differences between those. So, for instance, we have prepared two examples to show you. One is a list with differences between P&ID and 3D. So Andy, if you can just open it. This is a report which is resulting from Universal Reporter. It is displaying on one hand nozzle information from P&ID, and on the right side nozzle information from Smart 3D, and you see the differences marked with color. And this report can also be used to eventually automatically import data from 3D into P&ID or the other way around. So Universal Reporter also has the possibility to edit data between those applications and not only to print out differences. Let's move to the next example. The next example is showing differences between two revisions of P&ID. So on one hand, the data is coming from revision 1, on the other hand from revision 2. And you see the color-coded marks between, for instance, temperatures and pressures which have changed. So we can use this first column, which is called master tag, for instance, to only see which data has been changed, or eventually to see which are pipe runs only available in revision 1 but not in revision 2. And this is a very easy way to identify modifications, data that was added or deleted or modified. And of course, the same report can be done across several attributes. This is just an example for two different attributes. So, yeah, let's go to the next slide. So, as a summary, with Universal Reporter, it is easy to track changes between different stages of a project, but also between different applications for the same project or even for different projects. Data maturity checks can be performed, and also, last but not least, the quite powerful editing functionality of Universal Reporter allows also to change data in an easy way. Yeah. Having said this, I hand back to Andy.
Okay, thank you, Christine. Okay. Well, we're on the final business case, which is around visualization. So in this case, the 3D organization wants to provide clear information about the detailed design to different stakeholders of the project. Now, yes, you can use standard engineering systems to do this, but generically or typically the receiving companies and individuals may not have access or may not have the training to do that. So really industry standard formats such as 3D PDF, Acrobat 3D PDF, becomes a much more viable platform for that. You don't need the training, you don't need any specialist software, and it's not about replacing what is being done with standard review software because it simply doesn't do the same job. This is really about just extending that visibility of the 3D model and the data to these other people that don't necessarily have access or want to have access to that capability. So what we have a 3D design system, and this will support many different 3D design systems. We've got the 3D PDF engine software, and that then generates or publishes a 3D PDF file. So the nice thing about it is it's very compressed in terms of its file size, so it becomes very easily transportable. It's very easy to navigate just using the mouse. We can define the tree structure based on the attribute values. In this case, we're just showing it broken down by discipline, but it could be anything you like, really. And also, when we click on an object, we can see the properties for that object. Now, there are limitations to what the Acrobat Reader can do, so we felt it was important to add some additional capability. And we do that by embedding those commands within the PDF file itself. So if I send you this file, you open it up in your version of Acrobat Reader, you will see these commands because it's part of the PDF file. And just to give you one example, we can just basically say, let's do volume clipping. That volume clipping gives me the ability to put a box around that piece of equipment and then isolate that from a viewing perspective, or I can just say reset model. So very, very simple. I'm not going to go into all the features of this. That's what it's all about. Moving on though, what we've recently done is extended the capability by putting attribute highlighting, which is available at the time of publishing. So what that means is we can pick on any attribute we like and say, if the value is this, then turn it this color, and if it's something else, turn it a different color. So it could be used to report status of a particular project progress. So for example, the green line might be issued for construction and the blue might be ready for testing. It could be anything you like, but the basic premise is we can then color code at the time based on the attributes that we have. That then can be sent out to anybody who wants to review it as a portable document. The next thing that we've done is we've enabled volume clipping at the time of publishing. So we may have a number of different piping systems or different individual lines. And what we can do is say, okay, we want to publish that, but put a volume of maybe 3 meters around each one of those objects. So it could be equipment items that we're all automatically capturing a volume around. And we then have a series of automatically published PDF files for review and distribution. Because PDF files have a limitation in the size of model that they can store, we wanted to be able to expand the use of it to larger models. And so we came up with this master detail concept where effectively what we have is a key plan document. So the detail on this is very limited, but what it does do, it gives us an overall view of the plant. We've then broken the plant down into different sections as noted by the different colors. If we clicked on one of these colors, excuse me, it would open up a very detailed view of that particular area. And from that, we can then navigate back up and back into different detail views. So we have a way of navigating multiple PDF files with different levels of detail in for an overall plan. So that basically de-restricts the overall size that you can have. But what you are effectively doing is publishing a series of PDF files which have inbuilt hyperlinks for navigation. The final thing on this visualization side of it is the PlantDocument Designer, and this enables us to publish a group of documents into a single PDF file that are hyperlinked together. So in other words, we could look at basically an isometric here, and as we click on a valve, it will automatically highlight that valve in the 3D model. And that's because we're using the power of the Smart 3D platform and all the things that go with that. So that's also available for anybody that's interested. Okay, so we've covered the business cases. Just to summarize what we've seen, we've done a very brief overview of different engineering workflows, covering the P&ID data quality, 3D symbol creation, spec data quality, migration of PDS data, progress reporting, and now we've just completed visualization. So hopefully we've demonstrated through the technology that we've been bringing forward here that we can improve the efficiency of these engineering workflows.